The universe is vast. It is an immense, dark ocean dotted with islands of light we call galaxies. Within these galaxies, stars are born, they live, and they die. And sometimes, just sometimes, they send us a message. Not a message of words or sounds, but a physical object. A traveler cast out from its home system, wandering the interstellar void for millions, perhaps billions of years. We stand on our small blue world looking up, and we have just spotted another one of these cosmic messengers. It is called 3I Atlas, the third interstellar object ever detected by humanity, and it is heading our way. Its journey through the darkness is a story written in the language of physics and chemistry. It found this faint speck of light moving against the background of distant stars. It was a true alien, a visitor from another star system, carrying with it the primordial secrets of its birthplace. And as it gets closer, it is beginning to wake up. As 3I/Atlas ventures deeper into our solar system, it is putting on a show. It is changing. Like a celestial chameleon, its appearance is morphing right before our eyes. Or more accurately, before the sensitive eyes of our telescopes. When it was first spotted far from the sun, it was a dim, reddish object. This is what we might expect from a body that has been battered by high-energy cosmic rays for millions of years. This constant bombardment creates a crust of complex organic molecules, a sort of cosmic sunburn that gives the surface a dark, reddish hue. On September 7, 2025, a team of astronomers in Austria, using a modest observatory, captured a series of stunning new images. The object was no longer simply red. As it drew closer to the sun, its warming core began to release gases, forming a glowing atmosphere called a coma. And this coma was not red. It was glowing with a distinct ethereal green light. The transformation was startling. The object that had entered our system as a dark, ruddy traveler was now cloaked in a vibrant, verdant shroud. It was as if the visitor was shedding its old, travel-worn coat to reveal something new and brilliant underneath. This color change is a profound clue to the object's composition. The heat from our sun acted as a key, unlocking the frozen materials within and allowing them to escape. The change from red to green is not just a pretty light show, it is a chemical reaction unfolding on a cosmic scale. So, what causes this dramatic shift from a dull red to a brilliant green? The answer lies in the chemistry of comets, or at least what we know about them. The green glow is a specific chemical signature. It is the color produced when a molecule called diatomic carbon, or C2, is bathed in the ultraviolet light of the sun. Diatomic carbon is essentially two carbon atoms bonded together. This molecule is very unstable and does not last long. It is created when more complex organic molecules, frozen deep within the object's core, are broken apart by the sun's energy. So seeing that green light tells us that 3I/Atlas is rich in these carbon-based compounds. The process begins deep inside the object. As the sun warms its surface, the heat slowly penetrates the outer reddish crust. When this warmth reaches the pristine, ancient ices below, they begin to vaporize, erupting outwards to form the coma. These ices are not just frozen water. They are a cocktail of frozen gases, molecules, parent molecules of diatomic carbon. Once these parent molecules are freed from the icy nucleus and float into the coma, they are exposed to the full force of solar radiation. The sun's ultraviolet rays are energetic enough to snap them apart, and in that process, fleeting molecules of C2 are born. As 3I/Atlas gets closer to the sun, its activity is ramping up in other ways too. The coma, a beautiful green cloud, gas, dust, surrounding the object's solid nucleus. It's growing larger and brighter with each passing day. Think of it as a temporary atmosphere, spontaneously generated by the sun's heat. When 3I/Atlas was far away, it was just a point of light, a bare nucleus. But as it warmed, the ices started to sublimate, spewing gas into the vacuum of space, spewing dust into the vacuum of space. This material expands outwards into a vast, glowing sphere. That sphere can grow larger than a planet. The coma's behavior is particularly intriguing. Its expansion is not perfectly uniform. There appear to be jets and plumes erupting from specific active regions on the nucleus surface. And then there is the tail, or more accurately, the tails. Most active comets display two distinct types of tails. The first is the dust tail. The second tail is the ion tail, also called the plasma tail. Watching these two tails develop on an interstellar object is a spectacular sight. To dig deeper into the mysteries of 3I Atlas, astronomers turn to one of humanity's most powerful eyes on the sky, the Very Large Telescope, or VLT, perched high in the Atacama Desert of Chile. Its giant mirrors can collect faint light from the distant cosmos and spread it out into a rainbow of colors, a spectrum. This spectrum is like a chemical fingerprint. Every element and molecule absorbs and emits light at very specific wavelengths, creating a unique pattern of bright lines and dark lines. By analyzing the spectrum of light from the coma of 3I Atlas, scientists can determine exactly what it is made of, even from hundreds of millions of kilometers away. The VLT's findings were both familiar and honestly deeply strange. As expected for an active comet, the spectrum revealed a strong presence of cyanide, or CN. This is a simple molecule made of one carbon atom, one nitrogen atom. Like diatomic carbon, it is formed when larger parent molecules frozen in the nucleus are broken down by sunlight. Cyanide is a very common ingredient in the comets of our own solar system, so finding it in 3I Atlas was not a huge surprise. But the VLT found something else, something that really made everyone pause. The spectrum showed the clear signature of nickel atoms. The puzzle is that 3I Atlas was still quite far from the Sun when the nickel was detected. This was a significant anomaly, a clue that did not fit the standard picture of a comet's behavior. With so many strange signals coming from 3I Atlas, the color changed the unusual coma. The unexpected nickel scientists are busy forming theories to explain what it is. The simplest explanation, and the one most astronomers lean towards, is that 3I Atlas is just a comet. It may be a slightly unusual comet with a chemical composition different from those in our solar system, but a comet nonetheless. This is the principle of Occam's razor. The simplest explanation is usually the correct one. In this view, the object is a natural chunk of ice and rock born in another star system, and now behaving as we'd expect any icy body to behave when it first approaches a star. However, there is another, more provocative theory. Championed by figures like Harvard astronomer Avi Loeb, this hypothesis dares to ask a different question. What if it is not natural? Loeb famously suggested that our first interstellar visitor, Oumuamua, might have been an alien probe because of its strange, non-cometary acceleration. He now points to the anomalies of 3I Atlas as potential evidence for a similar, extraordinary origin. This is, of course, an extraordinary claim, and it requires extraordinary evidence. But the alien probe hypothesis serves as a valuable reminder to keep an open mind. To truly appreciate how special 3I Atlas is, we should place it in context with its predecessors. It is the third member of an exclusive club of known interstellar visitors. The first was one Oumuamua, discovered in 2017. Oumuamua was a complete enigma. It was small, it was reddish, it was highly elongated. As it sped away from the Sun, it accelerated slightly. It showed no visible coma. Its nature remains one of the greatest astronomical mysteries of the 21st century. The second visitor, 2I/Borisov, arrived in 2019. Borisov looked like a classic long-period comet. Borisov acted like a classic comet. It had a large, visible coma. Its composition was remarkably similar to our local comets. Borisov was reassuring. Normal comets from other star systems exist. Now we have 3I Atlas. It falls somewhere intriguingly between the two extremes. Unlike inert Oumuamua, it is clearly active. However, its behavior is not entirely normal. 3I Atlas is the perfect learning opportunity. The arrival of 3Y Atlas has ignited a vibrant and healthy debate within the scientific community. The story of 3I Atlas is far from over. In fact, the most exciting chapter is just about to begin. Every day, the interstellar traveler gets closer to our Sun and to us. Its journey will reach a critical point on December 19, 2025. On that day, it will make its perihelion passage, its closest approach to the Sun. It will be at its hottest, its most active, its brightest. This will be our best chance to study it in unprecedented detail. All the world's greatest telescopes will be pointed its way. Hubble Space Telescope, James Webb Space Telescope. What will we see? Will the increased heating cause the nucleus to fracture? Will the chemical signatures in its coma change? We will be watching for any changes in its trajectory. This will be our final opportunity to observe it before it fades into darkness. So for now, we watch and we wait. Is 3I Atlas a messenger from a planetary system much like our own? The cosmos is speaking. Are we ready to listen?